5.4 Enthalpy of reaction. The change in enthalpy, delta H, is the enthalpy of the products minus the enthalpy of the reactants. This quantity, delta H, is called the enthalpy of reaction or the heat of reaction. When a mixture of hydrogen gas and oxygen gas is ignited to form water vapor, the resultant explosion produces a ball of flame. Because the system releases heat to the surroundings, the reaction is exothermic, as indicated in the enthalpy diagram. The truth about enthalpy. 1. Enthalpy is an extensive property. This means that it does not depend on the amount of matter present. 2. The change in enthalpy for a reaction in the forward direction is equal in size but opposite in sign to the change in enthalpy for the reverse reaction. 3. The change in enthalpy for a reaction depends on the state of the products and the state of the reactants. Sample exercise 5.4. How much heat is released when 4.5 grams of methane gas is burned in a constant pressure system? Our goal is to use a thermochemical equation to calculate the heat produced when a specific amount of methane gas is combusted. According to equation 518, 890 kilojoules is released by the system when 1 mole of methane is burned at constant pressure. Therefore, our change in enthalpy is negative 890 kilojoules. Equation 518 provides us with a stoichiometric conversion factor, that is, 1 mole of methane yields negative 890 kilojoules. Thus, we can convert moles of methane to kilojoules of energy. First, however, we must convert grams of methane to moles of methane. Thus, the conversion sequence is grams of methane, which was given in the problem, to moles of methane to kilojoules. By adding the atomic weights of carbon and 4 hydrogen, we have that 1 mole of methane equals 16 grams. We can use the appropriate conversion factors to convert grams to moles to kilojoules. We start with 4.50 grams of methane in the problem. We're multiplying by the first conversion factor, which converts grams of methane to moles of methane using the molecular weight, and then the second conversion, which converts moles of methane into kilojoules, and this again was accomplished by using equation 518. Our final answer then is negative 250 kilojoules. The negative sign indicates that the system released 250 kilojoules into the surroundings. For practice, hydrogen peroxide can decompose to water and oxygen by the following reaction. Calculate the value of Q when 5 grams of hydrogen peroxide decomposes at constant pressure.